Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. I'm going to talk about calorimetry today. Calorimetry deals with the heat transfer between two objects at different temperature. We all know that heat is a form of energy and that can be generated by other forms of energy like say electrical energy or friction or any other form. Okay. Temperature is a feeling of hotness or coldness of an object. When two objects at different temperatures are brought in contact of thermally conducting material, then the heat is transferred from the hotter object to the colder object, and finally the temperature of the two objects come at a common temperature. Okay. Heat capacity of a substance is the heat required to change the temperature of that substance or object by 1 degree Celsius. So if we want delta T degree change in the temperature, say for example we want 10 degree change in temperature of a substance and it requires say maybe 50 joule heat, then the heat capacity of that substance, that if you want to change 1 degree Celsius, then it will be 50 joule divided by 10, and that is equal to 5 joule per degree Celsius. So this becomes the heat capacity of the substance. Okay. But the heat capacity is not independent of the mass. In other way, we can say that if I have to increase 1 degree Celsius temperature of a substance which is maybe of mass 5 kg, and if I have to increase the temperature of a substance which is same type of substance but is double of mass, then I'll have to increase the heat to double. So it is not independent of the mass, and that is where the specific heat capacity comes. The specific heat capacity, it is the heat required to change the temperature of a body by 1 degree Celsius, and that body has to be of 1 kg mass. Okay. In other words, you can say that if the body is of m kg mass and I want a temperature change by delta T degrees Celsius, and for that I require Q amount of heat, then for 1 kg of mass I need the same delta T degrees Celsius, I need Q upon m heat by unitary method. And if I want that 1 kg of mass and that temperature to be changed by 1 degree Celsius, then again by unitary method it will be Q upon m into delta T. So the specific heat capacity, which is Q upon m delta T, is the heat required to change the temperature of 1 kg of mass by 1 degree Celsius. And that's how the specific heat capacity becomes mass independent, and that is characteristic of the substance. It depends on substance to substance and the material of the substance, that what is the specific heat capacity of the substance. Now, basis the definition of a specific heat capacity, then it is just a rearrangement of this equation, and then you can very easily find out that the heat required to change the temperature of m kg of mass by delta T degree Celsius, it will be m times C times delta T. So this is the equation used to find the heat required to change the temperature of m kg of mass by delta T degree Celsius. Okay. Now let's talk about the principle of calorimetry. It's very simple. you bring in contact two bodies which are at different temperature. One is hotter, another is colder. There is a thermal conducting material through which these two bodies are connected. So heat will flow from the hotter body to the colder body. And finally, they will reach to a common temperature which is T degrees Celsius. It means the hotter body will get colder, colder body will get hotter, and finally they reach to a final temperature which is T degrees Celsius for both bodies. So principle of calorimetry says that the heat lost by the hot body will be equal to heat gained by the cold body, with the assumption that heat has not been lost in any other form. It has gone from one body to another body only. Okay. Now let us use this formula, which is Q is equal to M times C times delta T. The hotter body mass is M1 and specific heat capacity is C1. And the temperature change for this body has happened from T1 degrees Celsius to finally it has come to T degrees Celsius. So the change in temperature is T1 minus T. So the heat lost by the hot body will be M1, that is mass of the body 1 is M1 into a specific heat capacity C1 multiplied by T1 minus T, because that is the temperature change which happened in this body. From higher temperature it came to a lower temperature. Okay. And for the colder body it is gaining heat. Whatever heat is lost by the hot body, that is gained by the cold body. So for it, again the same formula will be used, but in this case mass of the colder body M2, the specific heat capacity of the colder body C2, and T is the higher temperature. This cold body has got its temperature increased to T degrees Celsius from a lower temperature T2. Therefore, it will be T minus T2 is the temperature change. Be careful about this. In this one, that is T1 minus T, because it is hotter, so this temperature is high. In this case, the cold body reaches to the higher temperature, therefore it is T minus T2. Right? So now let us see how we use the principle of calorimetry. There is a problem given that a container has 8 kg of water at 25 degrees Celsius. 2 kg of water at 80 degrees Celsius is poured into it. We have to calculate that what is the final temperature of the water. And here we need to neglect whatever heat absorbed by the container. Meaning thereby that whatever heat is lost by the hotter water is gained by the colder water. Okay. So let's map that problem in this kind of environment where we have learned the principle of calorimetry. So there is one container which is colder because it is operating at 25 degrees Celsius. It has water and water is at 25 degrees Celsius and it is having mass of 8 kg. The mass of water is 8 kg. The specific heat capacity of the water, let's assume that it is C2, right? That will be equal to C because the hotter water which is getting poured into it, suppose there is a container and from that container you are pouring the water into it. So this water is at higher temperature. It means the M1 is equal to 2 kg of water you are pouring into that container and it is at 80 degrees Celsius. Finally, both these water, when the water is poured, the final temperature reached of the combined water is T degrees Celsius. Now, with the principle of calorimetry, the heat lost by the hotter water will be equal to M1 C1 T1 minus T. and the entire heat is gained by the colder water, and that will be equal to M2 C2 T minus T2. Now here also, because it's the same water, so specific heat capacity of water is also equal to C, whatever be the specific heat capacity of the water. Now you can write 2 multiplied by C multiplied by T1, which is AT minus T, and that is equal to 8 multiplied by C multiplied by T minus T2, which is equal to 25 degree Celsius. This is degrees Celsius, not 250, it is 25 degrees Celsius. So then my heat capacity gets cancelled because it is the same on both sides, and therefore this becomes 160 minus 2T, and this becomes equal to 8T minus 200. And therefore I can write 10T is equal to 360, and therefore T is equal to 360 divided by 10, which is equal to 36 degree Celsius. So final temperature when this hot water is poured into this cold water container will be equal to 36 degrees Celsius. With this example, you would have been very clear now how the principle of calorimetry can be used in solving the problems. Thank you.